This is a Friday Shoes production. This is lesson 8-1 in our books on page 417. It's the second day we're talking about lesson 8-1. And our target today is I can simplify algebraic expressions by combining like terms. Yesterday was the distributive property. Let's talk about the different parts to an algebraic expression. It says when plus or minus signs separate an algebraic expression into parts, each part is called a term. And you can kind of see they're talking right here. You can see a little bit of an example here. Negative 4x plus 12 plus x is 3 terms. The numerical factor of a term that contains a variable is called the coefficient of that variable. So you can notice here, there's a negative 4 in front of that x. That number in front of the letter is called a coefficient. And there you have it. Another vocabulary word there. Now, like terms contain the same variables to the same powers. For example, 3x to the second power and negative 7x to the second are like terms because the x squareds are the same. It's x to the second power. So the letters have to be the same and the powers have to be the same. Another example, so are 8x to the x times y to the second power and 12x times y to the second power. Notice the x, y into the second power are identical. But notice this, 10x to the second times z and 22x times z to the second are not like terms. And the reason why is the exponent is on the x on the first one, it's on the z on the second. Two different things. Looks like they might be the same, but they're not. A term without a variable is called a constant. So just simple numbers like 4, 5, 20, 73, negative 2, those are called constants. Constant terms are also like terms. Real quick matching game here. Watch me match the like terms. You can try to do this in your head right now and say which ones go together. I'm going to start with this 4 just because it's over on the left. And this 4 matches up with any other constant number just by itself. So I see 17 by itself, so those two go together. How about AB? Does it have, notice the exponents on those are not there, which means they're ones actually, A to the first, B to the first. Are there any other A, B's? And that's all. Some of you might say this is, but no, it's not. That one has a second power on it, so those don't go together. Again, you're just looking at the exponent and the variable and the exponent. How about this x? Does that go with anything? Sure does. X goes with this 3x because the variable is the same and the power on the variable is the same. Don't worry about the 3. That's the coefficient in front. We don't have to worry about that. When you're looking for like terms, you just look at the variable and the exponent. How about 4g? Do we have another g somewhere? Yeah, we do. We have 4g and 10g. So those things go together. Those are like terms because of the g. Oh, I see the 7x y to the second and 5x y to the second. Those go together. And then, again, this is not like with that because of that too. So we've got, how many different types do we have? 1, 2, 3, 4, 5, and 6 different types of terms there. All right, you go ahead and look at this example here as we walk through and identify the terms, like terms, coefficients, and constants in the expression 6n minus 7n minus 4 plus n. Well, first off, as we were doing this yesterday, you always change your subtraction to addition. So you're going to notice that they've taken these subtractions and actually changed them into additions, adding the opposite. So you can see the difference here. There's an adding negative 7 and an adding negative 4 right there. Step 1 is to do that. Step 2, let's identify the terms. Now notice the terms are 6n, negative 7n, negative 4, and 1n, or n. Those are the same. Next thing is, let's name the like terms. What goes together? Well, if you notice, the 6n, the negative 7n, and the n all have an n with no exponent on it. Therefore, they all go together. So those are like terms. Our coefficients are the numbers in front of those letters. So notice they got a 6, a -7, and we always have a 1 in front of any number that's by, or letter that's by itself. There's a 1 in front of it. And the way you remember that is 1n really means 1 times n. And if you remember, 1 times anything is the anything. So it's n. So just know there's a 1 always in front. So that's a coefficient as well. And we have one constant term, which is just, again, the numbers by themselves. So that's -4. All right, you give it a shot here. Name the terms, like terms, coefficients, and constants. Come on back, see how you did. Let's look at G here. Again, let's name them all. It says 9y minus 4 minus 11y plus 7. Now, remember, any subtractions you want to change to addition. So if you notice there, we've got 9y plus -4 plus -11y plus 7. What are the terms? Well, we've got a 9y, we've got a -4, we've got a -11y, and we've got a 7. Let me put in my commas there. So we've got 4 terms. What are the like terms? Well, like terms have to have the same variable and exponent. So I know I've got a 9y and a -11y. Those two go together. And then there's also, so we'll say those go together. Let me circle them. And then we also have -11y, or excuse me, not that one. Let's toss that back up. I'll throw that away, actually. And let's see here. We've got, the -4 and the 7 go together, because those are just constant numbers with no exponents. So those do go together. All right, so those are the two sets of things that actually go together called like terms. How about coefficients? What are the coefficients? The numbers in front of the letters. So we've got, obviously, we've got a 9 right here. And we also have a -11. All right, so those are the coefficients. And then how about the constants? Any numbers just by themselves, and we call, of course, those are the -4 and the 7. So notice they can be more than one thing. How about the second one here? 3x plus 2 minus 10 minus 3x. Well, we've got to change those subtractions to addition. So there we go. I've done that for you. And now let's find our terms. We've got a 3x, we've got a 2, we've got a -10, and we've got a -3x. So those are our 4 terms. What about like terms? Which ones go together? Well, obviously you can see that the 3x and the -3x go together because they both have a variable of x on them. So those two go together. And then let's see here, we got the 2 and the -10. Those go together because they don't have a variable. Those are just constants, and constants are like terms, so they go together. There you go. All right, how about our coefficients? The numbers in front of the letters. All right, we've got a 3, and we've got a -3. So those are coefficients. And our constants are just numbers by themselves. Looks like we got, again, our 2 and our -10. So those two numbers are the constants. Hopefully you did well on that one. All right, an algebraic expression is in simplest form if it has no like terms and no parentheses. You can use the distributive property to combine like terms. This is called simplifying the expression. So again, we're looking to combine things that go together. It's kind of like the matching game. You organize things together, and we, again, want to eliminate parentheses if possible. So we have simplifying the expression 4y plus y. Let's try that one. What do we have? Well, we notice that 4y and y are like terms because they both have y. Let's not forget that the y by itself there actually has a 1 in front of it. So we have 4y plus 1y. Sometimes I like to say it this way. I have 4 y's plus 1 y. How many y's do I have? Well, when we put those together, we actually add the 4 and the 1, and we have 5 y's, or 5y as we say. That's called simplified. Notice we started with 2 terms. Notice they were alike, and we combined them together, add them together by adding the coefficients. And now we have, notice, one term. So that's why we call it simplifying. We went from 2 to 1, and 1 is simpler than 2. And these are equivalent, and that's what this statement says here. They're saying basically this is the same equals this. So you can plug numbers in here for y, plug a number in for y there, and plug a number in for y here, and it should be the same value, meaning 4y plus y does equal 5y. You can put whatever number you want in there, and that will be true. Left side will equal the right side. Let's look at example 7. Simplify the expression 7x minus 2 minus 7x plus 6. I notice that it has subtractions in it. So the first step is, well, let's notice that 7x and negative 7x are like terms. I would like to do it this way. I don't think they do it here for you, but I'm going to change these to addition. Then we can talk about this line. 7x plus negative 7x are like terms, and negative 2 and 6 are also like terms. There it is. There's that where they change it. So now you see where they've changed it to addition. Of course, let's put the things that go together together. So that's why they've taken 7x and negative 7x and pushed it together. And they've also put the negative 2 and the 6 next to each other. And notice you can only do that because we've changed that to addition. You can't manipulate subtraction. Remember, 5 minus 2, that doesn't equal 2 minus 5. Those are two totally different things. But addition, when you switch 5 plus 2 and 2 plus 5, those are the same. So if you can change things to addition, it makes it a lot easier to move things around and organize. So here we are. Of course, we have 7x's plus negative 7x's. You're adding the coefficients. The coefficients are the negative 7 and the 7. And when you do that, you'll see what happens. We end up with 0 there, 0x. And then we added the negative 2 and the 6 together, and we got 4. So we end up with 0x plus 4. Well, what is 0 times x? 0x? That's going to be 0. 0 times anything is 0. So you end up having 0 plus 4, which is 4. There you are. So this whole expression, I want you to think about this. We're trying to simplify. Hey, make this easier. Make this look easier. Okay. This whole expression right here actually is the number 4. It actually equals 4. No matter what number you put in for x, the whole thing will equal 4. Well, looking at 4 is a lot simpler than looking at this whole thing. That's called simplifying. All right, you give it a shot here. We got 3 problems. Come on back, see how you did. Step 1, you got 4z minus z. Well, step 1 I'm going to do is put a 1 in front of that z. I see z's or x's and n's all by themselves. I put a 1 in front so I don't forget that there's a 1 there. And then, of course, I change everything to addition. So now we have adding negative 1z instead of minusing 1z. Same thing. Because it's a z on both of them, we can combine them and put them together. So we have 4 plus negative 1, which is 3. So we end up with 3z. There's your answer. How about this j over here? 6 minus 3n plus 3n. Well, step 1, I don't have to put anything in front of the letters because they're already numbers in front. Now I just change the subtraction to addition. Then I'm going to combine. I notice these n's go together. So I'm going to put those coefficients together because they go together. The n's go together, so add up negative 3 plus 3. Well, hey, that's 0. And 0 times n, 0 times anything is 0. So that's just 6 plus 0. So we end up with 6. That whole expression simplifies to 6. How about this last one, k? Again, I see subtraction, change that to addition. Once we change it to addition, of course, let's put things together, reorganize, put things together, go together. I've got the g's, put those together. Got the constants, put those together. Next step, add the coefficients of the variable terms. So then we got 2 plus negative 8. That's negative 6g. We, of course, add the negative 3 and the 11. That gives you 8. And now you say to yourself, oh, negative 6g is the negative 6g plus 8 is the answer. There you go. How do example 8 here? It says, at a concert, you buy some souvenir t-shirts for $12 each and the same number of CDs for $12 or $7.50 each. Write an expression in simplest form that represents the total amount spent. Well, let's put it into words. It says $12 for each t-shirt and $7.50 for each CD. And we're going to let X, because this is what we're looking for. It says write an expression in simplest form to represent the total amount spent. We have to know how many of these we bought. And we bought the same number of t-shirts and CDs. So let X represent the number of t-shirts or number of CDs that you bought. So our expression would look something like 12 times X. That would be the amount of money you spent for the t-shirts. And then $7.50 times X would be the amount of money you spent for CDs. So if we do that, 12 times X and $7.50 times X, notice they both have an X. So we can put the coefficients together. We add that up, 1950 times X. And remember what that represents, $19.50. So the expression $19.50 times the how many you bought represents the total amount spent. Now, that was pretty quick. Let's see if you can get this one. It says you have saved some money. Your friend has saved $50 less than you. Write an expression in simplest form that represents the total amount of money you and your friend have saved. Well, let's all start out by looking at it. It says you have to find the total, but how much did you save? You don't know. It doesn't say here, but we can come up with a variable that represents how much you saved. So step one is name a variable. So X we'll say is your savings, how much you actually saved. Now your friend, now you're going to use that X. That's the money that you actually have saved. So now your friend has saved $50 less than you. Well, how much do you have again? You have X, and your friend has $50 less than that. So take the amount that you have, X, see you don't have that number yet, but subtract off 50 from it. That represents your friends. So we have you as X, we have your friend as X minus 50, that's how much they have. And now what we have to do is add those two things together. So the total will equal your amount plus your friend's amount, which is X minus 50. And when you put those together, you notice we've got 1x plus 1x minus 50. Put those 1x's together, and now we have 2x minus 50. And that is our final answer. That is it. Don't hesitate to rewatch the video or look at the examples in the book or check out some of the personal tutor videos online on the online textbook. And as usual, this has been a Friday Shoes production.